Hi, and welcome back to the Reconciliation Project podcast, where we're formed by faith and informed by science. I'm Sam.
And I'm Hunter.
And today we're going to be talking about the problems associated with both the young and old Earth views of Age of the Earth. So do you want to get us started?
Yeah, so we see the scientific community overwhelmingly holds to the old Earth view, and we also see there's a significant group within the creationist community that also holds this old Earth view. So in this episode, we want to cover both sides and some of the problems that both sides face. Both sides will present certain pieces of data from science and say, hey, this supports our side, how do you answer? Mm-hmm. The first one, we're going to start with the old Earth view. The first one was a pretty big one with starlight. So we can actually observe that there are stars that are billions of light years away from Earth.
It's important to remember that a light year is a measurement of distance.
Thank you.
Contrary to the name, it's actually not a measurement of time.
It's how far light goes in 1 year.
So 1 light year is equivalent to 300 million meters per second, or those of us not in the scientific field and in America would say that it is approximately 984 million feet per second. So really, really fast.
And light going that quickly at 300 million meters per second or 984 million feet per second, that's a lot of space in 1 second.
Yeah.
And consider this over the time of an entire year times a billion.
Yeah.
That's really, really far away from Earth. And we're getting this light from these stars that are that far away.
Yeah.
And so, like I said, the question is, how is that possible if the Earth is only, and the universe itself also, is only 6,000 to 10,000 years old?
Mm-hmm. Yeah, which is kind of the big direct conflict with the young universe, young Earth timeline. But there are a couple proposed explanations. Obviously, if we're seeing light travel from billions of years away, we are assuming that is a constant speed that light is traveling. And there are a couple things that can mess with that or not mess with that, depending on the model that you're looking at. For example, Dr. Russell Humphreys suggested a time dilation model by gravity, which suggests that time may have passed differently in different parts of the universe based on gravitational pull by stars, other planets, black holes, that type of thing. Now, this makes a lot of sense if you've ever studied Einstein's theory of gravitational pull, which implies that if there's more gravity in one place, that light itself can actually be pulled toward that one place. Now, that seems really contrary based on what we know, because we're seeing light and gravity very differently here on Earth. We see gravity as, hey, we get pulled down to Earth, and we just see light shining down from the sun for the most part. That's very different than in space. So that's a little difficult to see and observe here on Earth, but we do know that based on Einstein's theories and based on what we've seen with gravity in space, that light can actually be pulled by gravity. So this would be a possible explanation. There is another explanation proposed by Dr. Barry Setterfield, which is the variable speed of light as well. This ties back to light traveling at a constant speed, and that in theory, light may not have traveled at that constant speed throughout time. In theory, there is the possibility that light may have traveled faster in the past. And therefore, we're actually seeing light, yes, that may be billions of light years away, but because it traveled faster, there is the possibility that it's getting here quicker than we would observe. The creationist community also argues a couple other points, and those points, while very important to look at, are not as based in scientific fact. Some of those are that light was created in transit. So when God created stars and moon and sun in Genesis, that he made those celestial bodies with light already exuding from them, and that light was already reaching the Earth by the time that they were created. But even within the perspective of, light was created in transit, the gravitational time dilational model makes most sense, that's still heavily debated, and it's really not a resolved issue, especially if you're looking at it from a scientific standpoint. People who aren't physicists really struggle with some of the physical models, and I can speak as someone who doesn't know as much physics. That's a really tough topic to have to deal with. And even if you can deal with physics, a lot of people in the scientific community won't accept the idea that, light was just created in transit. because there's no way to scientifically measure that. So obviously that's something that is a huge unresolved issue and still causes some problems for the young Earth community.
It is an interesting problem, though, because it does seem very convincing if we see these stars that are that far away. Mm-hmm. It does sound pretty convincing. I personally do hold to the more light created in transit view, mm-hmm. because we read in Genesis that God created the stars and all on day 4, and that includes the sun and the moon. I would think, based on a literal reading of Genesis, that when these celestial bodies were created, their light was already here on Earth. Mm-hmm. Meaning God could have created a star billions of light years away whose light was already there because, one, he's God, he can do anything, he is all powerful. I know that doesn't 100% resolve this issue because I think the scientific community does pose a valid argument in favor of old Earth using this starlight problem. Mm-hmm. So that is just my view with the light being created already here, yeah. or in transit.
Yeah. I think that that's a very well articulated view. I personally can't fully get behind the idea of light being created in transit simply because that's not measurable. If God created the universe, and of course the Bible says that let all the earth declare the glory of God. And obviously that means all of creation, not just the earth itself. So right. That includes starlight. So frankly, if we can't say, not that we have to have all the answers, but if it's not measurable in some way, shape, or form, either now or hundreds of years in the future, that's a little difficult for me to see. Now, granted, I do think that there is the possibility that that still could be the case. My thing is, though, is I think that falls more into the variable light speed theory, because you could say, oh, well, it was created in transit, quote unquote, but really what was happening was God created it, it had variable light speed, and it got there instantaneously. And so it seemed like it was created in transit when really it wasn't. So there is that argument that could be made as well. I also think that the gravitational time dilation model is really convincing just from the standpoint of how gravity and light works. And I think that that's really fascinating in and of itself. So I think both of those actually are better arguments, although I don't completely discount the transit model either.
Yeah, I think the gravitational time thing is really cool because we know the only thing that's faster than the speed of light is a black hole. Because even light can't escape a black hole, hence why they're black. So it is very possible that that's what happened. But I like I said, why hold to that? We also see in the first thing God created with creating the entire universe, then he put everything in it starting in day 4. So I would think even from the far reaches of the universe, that light would already be here. Because I would think even Adam and Eve in the garden would have been able to see these stars at night. As we've both said, this is a heavily unresolved issue, and we could sit here and debate this topic itself during our entire episode.
Yeah, and these are not the only ideas of how those could be overcome, how the billions of light years could be overcome. There are other options. These are just the 3 most talked about and most convincing.
And another piece of data that the scientific community loves to hold to is the radiometric dating component that seems to overwhelmingly support old Earth. But we're actually going to spend an entire episode talking about radiometric dating in itself, so I'm not going to get into it here. That's actually going to be the topic for our next episode, is looking at the radiometric dating, what it says, what it does, and how we can respond to it as young Earth creationists.
Absolutely. So please tune in for that.
But for now, we want to transition a little bit and talk about the young Earth view and the pieces of data that support the young Earth view. And I want to start with the ocean salinity problem, which very simply, there is not enough salt in the ocean for the Earth to be as old as they say it is. There is what's called a sodium or salt cycle that the ocean goes through. Every year we see approximately 458 million tons of salt mix with the oceans every year as a result of various processes, including but not limited to runoff, erosion, ion exchange, vents, and atmospheric dust. I'm not going to get into what all of these mean, but pretty simply, whether it be from erosion, from pieces of land getting into the ocean, or some of these other things I mentioned, a lot of salt is getting into the ocean. In contrast, on the other side, we see only 122 million tons are removed as a result of some of the same processes as well as some of the other processes. So these things that I mentioned, they also can help take salt out. And there's some things that I'm not going to get into that can take salt out of the ocean. So the question is, if the Earth is that old, how is the ocean not much more salty? As a result of these processes, it would only take around 62 million years roughly for the ocean to reach the salt content observed today. which obviously is far more than the 6,000 year time frame that we hold to. However, we also can see that a major event like a natural disaster can actually increase the salt dump into the ocean in any given year. A global flood especially could dump an enormous amount of salt into the ocean, which would reduce that time required from 67 million years to 1 million years. And we, as Bible-believing Christians, know that there was a global flood in history, that being the flood of Noah, that Genesis 6 through 8 records. And this would for sure have this effect of putting tons and tons of salt into the ocean, because we see not only did rain come from the sky, it also came up from the earth and splitting the ground and creating the continents, which would very, very likely put a ton of salt into the ocean.
Because this would not have just been surface salt. Yeah. This also would have been salt deep within, or what we know of today as the Earth's crust, which we'll probably get into Pangea, how the flood would have created continents, how the flood probably would have changed the Earth as we know it, probably in a later episode.
Now, there are some that will try to refute this salt problem by suggesting that the ocean's salinity has reached a steady state, meaning that salt leaves the ocean at the same rate that it enters the ocean. However, there are modern studies that say that, or that show rather, that salt still enters the ocean at a rate far greater than it leaves. And there are some that will also reference the ocean's aluminium cycle, saying that if the same logic that was used for the salt problem was used for the ocean's aluminium cycle, it would result in the idea that the ocean is only about 100 years old, which obviously is absurd. However, there are numerous processes that occur with aluminium that result in it exiting the ocean as much as it enters. This varies depending on what region of the ocean we're considering, but the overall amount of the metal is still consistent. Therefore, we cannot use this cycle as an overall way to determine the age of the ocean. So the overall point here is there simply isn't enough salt in the ocean for it to be as old as modern science suggests. And there are even some evolutionists that have acknowledged, hey, this is a problem with our view.
Mm-hmm. Now, it's important to remember that there's a very big difference between 62 to 67 million years and the 13, 14 billion years that the universe is expected to be, and or the 4-ish billion years that the Earth is expected to be. That's off by a factor of 10.
Yeah, it's off by a lot.
Yeah. So obviously there's a very big difference in both sides there. Obviously, I think there's the argument that could be made that skews more in favor of young Earth than it does old Earth, simply because if you can't reach a higher number, you automatically have to go with the lower number.
And so this salt problem reduces the age of the Earth
significantly
from 4.5 billion years to 67 at most.
At max.
If you hold to a global catastrophe, which a lot of ancient texts hold to.
Mm-hmm. Not just the Bible. The Epic of Gilgamesh records a ancient flood.
Yeah. To the level of Noah's flood that we see recorded in the Bible. Mm-hmm. A lot of ancient texts record a global flood happening. It's not just a biblical event.
Yes. But either way, if you do hold to that global flood idea, that does reduce it even further from 62 to 67 million years to about 1 million years.
Yeah. So this is a huge, huge cut down of time, but we're still not down to 6,000 years.
Mm-hmm. Which I think you have a little bit more to get into with carbon-14.
Yes. So talking about carbon-14 in diamonds. There have been diamonds that have been studied that were thought to be millions of years old by other methods of radiometric dating, which, like I said, we're going to get into next episode, the specifics of how that works. But they were dated to be millions of years old by other methods, not carbon-14, other methods. However, when studies were done to detect carbon-14 in these diamonds, not only was carbon-14 detected, but it was found at high levels, which indicates the diamond at max could have been 50,000 years old.
Yeah. So let's back up on that for just a minute and talk about diamonds themselves. Diamonds are metamorphic rocks that are formed under immense pressure over time that basically compress and compress and compress one rock to the point where it turns into another rock, which sounds crazy, but it's been documented and it happens. Diamonds in and of themselves are specifically made from carbon. So when you have these metamorphic rocks, they eventually come to the surface by either erosion, some other process, and that's how we get diamonds, where you get them on your finger, you get them for your fancy jewelry, you get them for different kinds of cutting tools, all this mess, right? But for the most part, they do contain carbon. And because they contain carbon-14, which is an isotope of carbon, which we talked about last time.
And as we mentioned last time, carbon-14 can only last to a traceable level of up to 50,000 years.
Yes.
So if we're detecting carbon in these diamonds that are thought to be millions of years old, we're detecting it at significantly high levels.
They
Suggests
cannot be that old.
They aren't even 50,000 years old, but maybe 20,000 years old or 25,000 years old, or maybe younger than that. Now, obviously, this doesn't say, oh, the Earth cannot be this old, but it goes to show that things that the scientific data are saying, yes, it's millions of years, may actually be far younger than science originally thought.
Yeah, and that's not to say that, again, to your point, that the Earth couldn't be older. That's just to say that the method of which the scientific community is basing their dating methods on is extremely flawed.
Yeah.
Now, could these diamonds have been there at the dawn of time? Potentially. Could they have not been? Absolutely. They could have been made yesterday, and we just don't know. The problem is when one method of dating is showing millions and millions of years old, and another suggests that they couldn't be more than 20,000 years old, then you have a pretty significant difference there, and at least one of your dating methods is flawed. Potentially both. But if you're going to look at that, you have to be able to take a step back and say, okay, yeah, that doesn't make sense. What's right here? Based on how we know carbon-14 dating works, we would argue that carbon-14 is more reliable.
Yeah, for sure, I agree. But the problem here that gets presented with the diamonds is diamonds that when they get found, they're tested for carbon-14. They're always being found with some traceable level of this material, which suggests they're far younger than they might seem. And the other thing is they're testing a diamond and the rock that it was found in. The diamond is found to be much younger than the rock, which would make sense. But when it goes from hundreds of millions of years to like 10,000 years, there's a huge difference
That's
there.
off by a very large factor.
And so it does raise questions.
Absolutely. But carbon-14 isn't just used for diamonds. In fact, we actually talked about in a previous episode how carbon-14 has been used for dinosaur fossils, and that these dinosaur fossils had been dated to 65 million years old, potentially even older, and we know that's not possible either. But another thing that we do want to talk about with dinosaur fossils is actually dinosaur tissues. Now, when we talk about tissues, we're talking about a collection of cells. When you talk about biology, you talk about how the building block of life is a cell. And if you get a lot of cells together of one type, that is a tissue. So you have blood tissue, even though it's liquid. You have skin tissue, that's solid. So there are different types of tissues. So there was the discovery of tissues in dinosaur fossils by a woman named Mary Schweitzer, or Schweitzer, depending on how you pronounce it, either in the German or in the English. I'm not entirely sure how she pronounces it, so please don't go crazy on me for not being able to pronounce her name. I'm sorry. But she actually discovered soft tissues, collagen, and blood vessel-like structures in dinosaur fossils, which is really surprising, and we'll say why. Obviously, organic material decays very, very quickly. Anybody who's had meat that's gone bad knows how quickly stuff like that can go bad. However, we're seeing dinosaur tissues that supposedly are millions of years old that still have these cells that, oh, by the way, are viable. They're alive. They're not dead. It's not, oh, they're dead, but we can still see them. They're still functioning as living cells, which is crazy. Now, obviously, we need to ask the question of, could this even last millions of years? Preservation over deep time seems really unlikely in this case. And this is used as pretty strong evidence for a young Earth timeline. But for the sake of balance, we'll also bring in points of scientific data that could point to this being preserved for longer. Some scientists do propose a process called chemical stabilization. An example of this is iron preservation. And this is a way of preserving tissue in a chemical way so that it can last for a very long time. But the question then becomes, how long can that actually preserve for, and what are the conditions for it? Chemical stabilization, based on our research, shows that it can only preserve for anywhere from hundreds to thousands of years, not millions. So that automatically throws the time out. On top of that, there needs to be an anaerobic condition, so no oxygen. That's what anaerobic means. Acidic and cold conditions. Now this makes sense because fossils are buried underground where there's not a lot of oxygen. Soil tends to be more acidic. And, when you're so far under the earth, it tends to be pretty chilly. So that makes a lot of sense from the fossil standpoint. But again, the time component for chemical stabilization is way off for millions of years and doesn't make sense.
Yeah, because these fossils are getting dug up from rock that, again, as I said before, is dated to millions of years. And the fossils are getting dated to millions of years, yet when they go in, they're finding soft tissues that, as you said, are viable. So that throws up a question of, okay, how is that possible? Is this possible?
Yeah.
And it raises up one of two options. Either it's not possible and the thing isn't as old as it seems, or there's some process that we just don't know.
Which is completely possible.
But chemical stabilization, either in nature or in a lab, either way you do it, it does not last this long. Dr. Ron Marks, professor of organic chemistry at a local university to us, discussed this issue in a little bit. And he said that he could do every organic chemical process he knows of to try to preserve a piece of tissue in a test tube. He could put every chemical that he would use to preserve something in it, seal it up, put it away. And even after a couple of years, it could have broken down.
Yeah.
So we can't really do it in a lab. And in nature, it doesn't work either.
And it's important to note, too, that as weird as this sounds, more often than not, the lab is going to last longer than nature. Nature has more unpredictable factors than a lab does. A lab, you can control pretty much everything, minus maybe one or two things. Nature, everything is variable all the time. Nothing remains constant. It's going to go crazy like haywire. And oh, by the way, even from the perspective of, let's say that there was a fossil way deep down in the earth that was super cold and had no oxygen and whatever, any earthquake, any major terrestrial event could potentially shift the rock and change those conditions automatically.
Yeah. And if you stretch that over millions of years time frame, especially when during those geologic times we're seeing things like earthquakes and volcanic activity and ice ages.
Yeah.
That's going to start changing this a little bit.
And oh, by the way, the statistical likelihood that nothing would happen is so astronomically small the more time passes that it seems more and more unlikely the more time you're attributing to the age of these fossils.
So the overall issue here is we should not be able to find living tissues and living cells in these fossils despite how well fossilized they are.
If they're as old as they say they are.
If they're that old. Because, like I said, if I can go into a lab and try to preserve a piece of tissue with every chemical preservative known,
and it still won't last.
And it still doesn't last that long, maybe a couple of years, how would it be possible for, in nature, which fossilization obviously is a different process than what we do in a lab. I don't think we can make our own fossils in a lab, not with a test tube. But in nature, it still doesn't make sense that this would last millions of years.
There are too many variables to consider.
Yeah. So overall, you can see there's a lot of issues that both sides can bring up. And I think both sides present valid arguments, and both sides will debate and discuss, well, this is why I see it this way, this is why I see it this way. But neither side is going to get any closer to an agreement. At the end of the day, this comes down to how you view the evidence and what your worldview is.
Yeah, which is going to determine how you assess anything.
Yeah, so. Which earlier on, I think we said we're not trying to debate with this podcast, but we are trying to present what the science says and suggest, as well as share our views. But the reality is we could sit and have a conversation all day and debate these topics and still not get anywhere.
Yeah, and that also comes down to the fact that we still don't know everything.
Right.
Science never officially proves anything at all. People will say, oh yeah, well, science has proved X, Y, Z. No, that's not the case. Science has shown this repeatedly, but it hasn't proved it. Science never proves anything. Yeah. It can only offer data points.
Yeah. That's why there's only a handful of laws in science, like the law of gravity. Everything falls. But the day that something starts floating vertically up, it's going to change that.
Yeah.
Odds are that's not going to happen, but it could change. The point is science is always changing. There's nothing that ever gets proved. That's why we don't want to use the term, well, science proved this, because it doesn't. The science suggests something or science points to, but science never proves anything, which is why during this podcast, we're not trying to prove creation or prove a young earth or prove that God exists. which I don't think God intended. I don't think he intended for us to be able to prove that he exists, because at the end of the day, it is a Christian faith, not a Christian proof. And with that, that will conclude our discussion on most of the problems. But next episode, we'll finish up our series on the age of the Earth, and we'll discuss the topic of radiometric dating in more detail, and we'll also look at the assumptions involved in the process that lead to overall flawed data that I think you mentioned a little bit. But for now, we want to thank you for listening to the Reconciliation Project podcast, where we are formed by faith and informed by science. We wanted to share with you that if any of you have a question that you would like us to discuss, or if you caught something that we may have said that was incorrect, or just something you want to reach out to us about, feel free to do so. We have an email link in the description below, or if you are unable to access that, it's reconciliationproject.contact@gmail.com. And we encourage you to reach out with any inquiries or things you would like to discuss via that email. Again, thank you for listening, and we hope you will join us next time.